very much. This is going to be a different talk from the talks that we've had today. I've been really excited to be able to see a lot of forward-looking glimpses at what Keycloak will be, especially from shared by the maintainers and some of the upcoming standards and implementations. Um, this is a talk related to the fact that we, Phase 2, end up implementing a lot of Keycloak extensions, and then we end up supporting a lot of Keycloak extensions built by our customers. And I would say it's in the several hundreds now that we've been exposed to. And so one of the things that we endeavor to do with employees as well as people that we support is give them a picture of what it is to have best practices when starting, building, testing, and then running in production Keycloak extensions. So quickly, who is Phase 2? We're a Keycloak extension support and hosting business. So we have a couple lines of business. We started out as Keycloak Consulting Company. We launched a managed service, hosted offering, and then the hosted offering has an ISLA. And so we have multiple lines of business, but we're kind of all Keycloak all the time. Very quickly, who am I? GR, my name is Garth also, but I go by GR professionally. I've been starting companies for 28 years. Been using Java for 27 years. I started using Keycloak in 2017, and I started Phase 2 with a couple of other people in 2020. These are some of the people that I've worked for or sold companies to. Okay, so what are we doing here and why are we here? Keycloak is very mature, and for most identity use cases, it solves all of our problems, right? Well, if you have any reasonably advanced set of use cases, you end up building an extension. So for everything else, Keycloak has this incredible set of SPIs and implementations that allow you not just great programmatic extensibility, but you can also replace parts of Keycloak if you need to. So when you ask naively, perhaps, on one of the forums, Keycloak, I need you to include this feature in Keycloak, the often response is, you've got this ability in the API, in the SPIs, to implement it yourself. Go ahead and build an extension in order to achieve that custom functionality. And 99% of the time, that custom functionality will not make it into Keycloak, or not soon make it into Keycloak. So two kind of different ideas of what constitutes custom in this case. A lot of extensions are very highly specific to a requirement you or your company has, but there's also a lot of public extensions built by a lot of people in this room, built by our company, that has broad appeal, but hasn't yet either raised to the point where Keycloak wants to consider building it or accepting it, or is enough of a different use case that they would never accept it, but it would be adopted by a large set of the Keycloak community. Okay, this is one of the first responses I get when people are averse to building extensions, which is this error, 47, where they tell you this is an internal SPI and may change without notice. So it's people pretty frustrated because if you are in an environment where you think this can change, you're less likely to adopt it. Now, this hasn't really been an issue outside of the UI and some other minor interface changes, but it does mean that every extension you build, you need to validate with each new version. So one of the things we tell our customers is you need to decide on your tolerance for risk based on how much Keycloak uses it internally. So what I mean by that, for example, authenticator implementations. The entire authentication flow infrastructure is based on implementation of the authenticator interface. So it's unlikely that they're drastically, precipitously going to change it. However, the recently released, I think they're in preview or experimental, admin UI ability to build extensions in Java might change. Why? They don't use it at all internally to build admin UI functionality. And so you kind of have to assess your willingness to own something based on what they're doing internally and how much they've adopted something internally. Now, I will go back to that and say that's really intimidating. And there are things that are obviously stable in Keycloak that aren't really going to change. So I would encourage the maintainers in this room to take a look at that error and perhaps revisit a couple of the SPIs to understand whether or not they need this warning, because it really does affect when you're a builder or you're a customer building extensions. This has an effect on whether or not people will adopt Keycloak and people will adopt extensions. Okay, really quickly on audience and scope. The idea of this is to be at a beginner level. It's meant to answer the questions, I need to add or extend Keycloak, what's available, and how do I get started? So it's separated into a couple of sections: the build setup, information on the lifecycle of an extension, how to configure an extension, how to test an extension, and then a live example. So build setup, the POM file. I'm going to sort of gloss over the fact that I'm assuming you're a Java developer and I'm assuming you know what a POM file is. But the specific cases I wanted to get into are the use of a BOM file, use of annotation processors, giving us some version information that we can add to the server info aware provider factory, which puts information in the Keycloak UI, the use of test containers, and building a fat jar. So use a BOM. So what does this do? This gives us versions and dependencies that match the version of Keycloak that you're trying to build against. This is really useful. So the one I'm referencing here is Nico Kobler's BOM. It actually works a little bit better for building extensions than the one Keycloak distributes. And it gives us this advantage that you don't need to specify the version once the BOM is specified as a dependency management dependency. So that's recommendation one. Annotation processors. So one of the things that we've learned in our own development and operating the team internally that builds a lot of these extensions is just you want to make it as convenient as possible to add things without a lot of boilerplate code. So two of the ones we use really frequently are Google's auto service. What this does, it allows us to put in an annotation with the name of the provider factor class that you're implementing, and it builds all your SPI manifest files automatically and puts them in the right place. Super convenient, and it doesn't mean that, it means that you don't end up on a forum saying, I built my provider and it doesn't load, what's happening? Second one is Lombok, who I'm sure a lot of Java developers in the room are really familiar with. They have nice annotations like JBoss log. They also have a lot of annotations for creating data or record type classes. So those are two that we recommend when you're doing your build setup. Another one that a lot of people don't do is adding metadata. So one of the things here, this is what we call the Versionizer plugins by a former colleague. This allows you to add, who's the vendor, who's the project, what's the version, which Git SHA are you running, and it generates a class that you can then use. And it's really easy to use when you're building your server info or provider factory. I'll get to that in the demonstration. But between the build number and the Versionizer plugin, it gives you some ability to add metadata to the project that you can then use at runtime to reference when you're looking at problems. Test containers. I'll get a little bit later to how this is used. But you haven't used test containers. It's basically a Java API to spin up Docker containers while you're testing. So there's again, Nico Kobler built a test containers implementation specific to Keycloak, great JUnit support, great ability to quickly bootstrap a Keycloak Docker instance with the kinds of things that you would need, like relative path, like the ability to import extensions both from jar as well as from the local classes directory, and the ability to load resolved artifacts directly from Maven. Building a fat jar. So there's a question about whether or not extensions should be built as a fat jar or not. And should you do it or not is really based on how you're packaging and if there are other extensions in the mix. And the reason is, if you're building a fat jar, and let's say you have 10 extensions and they all include some specific jar, you may not want to build a fat jar that includes that jar 10 times. And one of the things that we do actually, so for some of our extensions that have highly specific dependencies, we will use the Maven Shade plugin in order to pull in the dependency and build a fat jar. But oftentimes, especially for the Docker image that we release, if you're building a project with a large number of extensions that have overlapping dependencies, we actually have a submodule in our Maven builds where we use, and I call it the old Maven ear plugin, because I don't know how many people are actually still using it, but it does a really good job of collecting all your dependencies in one place that then you can point a Docker file too and say, bring all these in and put them in my providers directory. Okay, let's talk quickly about the lifecycle and extension. Every extension implements provider, factory, and provider. What do they do? Provider factory sets up the provider. It's classic factory pattern. And then provider does the thing. Here are the methods that I'll get to in a sec. So important methods. We've got this init method when the provider is first starting. That's where you can get configuration and begin things. The one thing to call out in this case is during the init method, not all providers or other providers are necessarily loaded, and you don't have access to the Keycloak session factory. That's the next method, post init. Post init is called after all the other provider factories have been initialized. So you're sure that you have access to the other providers. And so you can do a lot of things, like you can set up default authentication flows for your new authenticator. You can add your roles to realms if you're building something that requires a new realm role or a new client role. Create. That makes the provider. So that's the thing that gets called for every Keycloak session to actually make the provider instantiation. And then close. Remember to clean up before your Keycloak shuts down. This is something that I see missing oftentimes from a lot of extensions. If you have resources, long-running processes, other things that need to get cleaned up, remember to implement close. So there's two additional interfaces worth calling out. Configured provider. There are many extension types like user storage providers that can be configured by the Keycloak UI. The configured provider interface allows you to set up those configuration properties. And the other one I've mentioned earlier, server info aware provider factory. This allows you to expose operational information about your extension into the Keycloak UI, which again, if you're debugging or if you have a customer that has 250 sites that needs to debug that all have different versions, you want to know very easily, hey, take a screenshot of your provider info with this operational info rolled down so you know what version they're running. Really useful. Okay, configuration. How can I pass configuration information to my extension? This is something we get a lot. And a lot of people end up using things like environment variables. And the reason they do is because it's kind of confusing. So it used to be this really nice XML in the Wildfly version. It was pretty clear how you were getting information, configuration information to an extension. The sort of tongue-in-cheek say, let's make this as confusing as humanly possible. But at the same time, in reality, you actually have to create a namespace such that you're getting the configuration information to the right place. So it's only loaded in the config scope when that extension is loading. And so the format here is, there are two ways to do it, but depending on how you're starting up your Keycloak, but I've used the environment variable format here, which is the name of the SPI, which, by the way, you might have to go into the Keycloak source code to figure out what that is, because it's not the same as the class name. The provider ID, which is the ID you gave your implementation, and then the variable name. So what it ends up yielding is these incredibly long names. And then it's pretty easy once you get there to get it out of the config scope object. Okay, testing. If you look into the Keycloak source code, there's actually a bunch of different ways, but the ones that are to be most prominent are the test suite Keycloak server and I don't know how to pronounce it actually, Archillion. These turn out to be great for the Keycloak source code and for that big tree, but are a little bit unwieldy for building extensions. So we recommend testcontainers, as I told you about before, which allows you to bootstrap a whole Keycloak and a Docker image with the extensions loaded. And then Cypress for doing UI-based testing. And one of the reasons we love Cypress, Killian may have this, we never figured it out, is you can record sessions and then you can use those files to replay in your tests, and it makes it really convenient to do things like test authentication flows and such. Okay, let's talk about test containers. So it's not sufficient just to load it into your POM file, but it is very convenient within your test to easily create a container, give it a context path, tell it whether or not you want to reuse the same container for all of your tests, tell it to get provider classes from your target classes directory or from dependencies. So this is an example of if you've got dependencies defined in your POM that you also want to load in, you can use what's called the Maven shrink wrap resolver, so the method at the bottom, to load those dependencies from the POM file, and then back up here, I'm calling get deps in with provider lives from. And so you can load other extensions if you're trying to do a comprehensive integration test. And then in the actual test, start the container. Before all your tests, you can grab a Keycloak admin API client very, very easily. You can get the instance. You can get other information like the auth server URL, and then you can use this all in your extension very easily to run your tests. Okay, what can I do? Where would I start? I had this slide in my talk at the February Keycloak conference. These are all implementations of providers. It's this huge world, and it's a little bit intimidating to understand where you would start. And so what I want to do, rather than like go through everything, is just do a real example. So one of the things I'm missing here is that I'm not going through all the potential extension points. The idea is that you'll get the setup, you'll build your setup from the POM recommendations, from the testing recommendations, and then you'll figure out, okay, what is it that I'm trying to do? At phase 2, we often approach things from a concrete user story perspective, as opposed to, okay, what is technically possible? And so in this case, we're going to build a generally useful webhooks extension to the Keycloak event system. So if any of you have used Stripe or many other modern APIs, they have a callback mechanism where you don't have to go in and get the events, but the events come to you via HTTP. Okay, in the process, we're going to use a couple of the SPIs to implement features. So first of all, we're going to add JPA entities so that the webhook definitions can be persisted. We're going to add some custom REST resources to create an API for managing webhook subscriptions, because that's the idea. You can dynamically add or remove webhook subscriptions. We're going to use the event listener SPI to capture the Keycloak events and dispatch them to the webhook endpoints. And as a bonus, we're going to use the aforementioned admin UI Java extension mechanisms to add to the admin UI to create, manage, and view the webhooks. Now, I'm going to go a bit fast, and the reason is I don't have a ton of time left, and the code is in the open source extension that I'll put at the link at the end. Okay, JPA entities. We are going to store entities in the database just like Keycloak is. So we need to create a liquid-based migration script. We need to create the JPA entities. We need to implement JPA entity provider and where we register entities and the migration script. And we're also going to create some model classes that wrap the entities. And as a bonus, we're going to create our own SPI so that we can provide a convenient and protected way of accessing the model classes, and completely modeled after how Keycloak does it. First of all, if you don't know, all of Keycloak's database migrations use a tool called Liquibase. You put your migrations in this folder, so it gets packaged with everything else, but it's just a normal Liquibase migration to add tables. This is an example of one of the tables in the extension, adding the webhook table. You create your JPA entities. If you're familiar with JPA, it's not specific to Keycloak. You add your queries, you add your annotations to the entity itself. I would refer you to JPA documentation for that. The Keycloak specific bit is there's an implementation of something called JPA entity provider. You do two important things there. You register your entity classes, as you can see in the first field in the first method, and then you tell Keycloak where to expect your changelog, so it can do the loading for you. Next piece is we're going to create model interfaces to wrap the entities. This is the same indirection that we do in Keycloak, so that we have an interface and then we have a concrete implementation of that interface. And then the bonus was creating our own SPI. So one of the neat things about Keycloak is that you're not just limited to implementing their SPIs, you can create your own SPIs and then you can implement those. And so in this case, we create a specific provider, webhook provider, and then we implement that. You can see it kind of gives us access to what we want the code to be able to do in webhook provider. Okay, next, custom REST resources. So interface here is called Realm Resource Provider, and we're trying to provide an API for the webhooks. Realm Resource Provider, the important method is get resource, returns a standard JAX-RS implementation. We need to remember to do a couple of things. We need to handle access control because Keycloak doesn't give this for free. And we also need to make sure we're giving auditability of our changes by adding admin events. So a couple of things. Here's the example of the get resource method. You can see there's just an annotated JAX-RS method with a get there. So remember to handle access control. So when we originally did this, I actually took Dimitri's code. I don't know where Dimitri is, but oh, there you are. I took Dimitri's code from Keycloak, which is a little bit more extensive. This subsequently is something we found in Keycloak. This is kind of how you end up with this admin permission evaluator object. And this is really useful because you can, just like Keycloak, say, okay, for this method, I want someone to have the view events realm management role. And so that gives us the ability, if we do this before we load our resources, it gives us the ability to call this and check permissions. Next thing is just, there's this really convenient construct called the admin event object. You can add arbitrary resource types to it and use their operation types. And this just allows you auditability in those admin events. So in this case, we're just saying a webhook was created, get the URI, get the representation. Okay, the actual event listener. So this is capturing the Keycloak events and then dispatching them to the webhook endpoints. In our case, what we do is we enlist something to run after the transaction is complete, and then we use a thread pool to send them. So it's not guaranteed that they'll get there, but if they get there, it's guaranteed that it actually happened after the transaction was completed and committed. And so you just really implement two core methods: on event for the event, on event for the admin event. And then the admin UI. This is the new method, which is really kind of an old method. It's the same component factory method that user storage providers were used, but now generalized. You implement this idea of UI page provider factory. There's also another one called UI tab provider factory. The problem with this is it only allows you to use component models. It doesn't allow you to do your own storage layer. So we had to do some duplicative work between webhook models and component models. But they give you a lot of hooks, pre-remove, on create, on update, that allow you to replicate what is happening in component model in your own models. But we have to go back to our REST resources and update those so they also update the component models. And if we release this before this new UI extension was released, we have to go migrate everything. And there's a lot of things we have to do. I hope that there's investment in this in the Keycloak side. It's great potential, but it does require you to do a lot to fit into their model of things. We use the configure provider interface I mentioned earlier. So basically, you just set up the configuration properties you want, and then they're persisted as component models. Okay, let's show a demo. We're going to quickly show the demo. First, I wanted to show provider info. So one of the things I referenced earlier is give people a lot of information about what is running. And that server info aware provider factory allows you to do that. As you can see, this is automatically generated and it gives me all those values for free. So if someone takes a screenshot, I'll know which version they have running. That's convenient. Let's go into a demonstration. So what is new about this? If you look at the bottom left, it says webhook. So that new Java method for updating the admin UI, it's added this additional tab, webhooks. And so it gives you, just based on that configured provider interface, it automatically generates this form for you. So let's say I wanted to create a webhook on this endpoint. This extension also allows for shared secrets for giving you a signed version of the payload, so you can verify it came from you. In this case, I just use a Java pattern. We've consolidated event types between login event types or user event types and admin event types so that individual webhook endpoints can receive both types. So it's a little bit different format than you may be used to. So in this case, you just do a Java pattern on the event type. I'm just going to say star for us now. So that gets saved. Let's go in here and make sure the extension is turned on. And you can see a post just showed up here. And so this gives you the entire event. And so in a reasonable number of SPI implementations, we were able to build this complete webhook, generalized webhook infrastructure for externalizing Keycloak events. I think that's all I wanted to show you. Oh yeah, I wanted to say thanks to all the community that is part of Keycloak, part of phase 2, the maintainers, authors, and contributors. Dimitri for BeerCloak. I would say when I started my journey 7 years ago and he released that, it opened my eyes to what is possible in terms of extending Keycloak. Thomas for everything, all the examples and all the generosity. Sven Torben, who's not here today, but he builds a lot of really popular extensions. And he did another talk in February that kind of inspired this. Nico Kobler, he's very patient. We are the co-moderators of the Keycloak discourse. He's totally awesome. Adorsus for the great event and the whole Keycloak community. So, any questions?
Thank you for the talk. So you showed that you use test containers to test your extensions. How do you configure your Keycloak, for example, enable event listeners and so on?
Great question. In that case, via the REST API. And so from test containers, you get a Keycloak REST admin client, and we use that to configure. I'm really excited, by the way, about the declarative idea or progress with Keycloak config CLI, because I think it's a huge missing piece. We actually, at phase 2, for our hosted system, built a migration system. It's not ideal, but it allows us a great deal of flexibility. And so it's kind of like Liquibase, but it's not declarative. It is incremental. So, but anyway, we just use the REST API to configure it. And if you look at the that repository, you can see the tests and how we set them up.
Thank you.
So I just wanted to ask to get back to the SPI configuration. Have you perhaps considered the new way how the SPIs are configured through the Quarkus distribution, the CLI options, and property files and stuff like that?
Can somebody repeat? Can you repeat that?
Yeah, so I just wanted to get to the SPI configuration.
Yeah.
So you mentioned that it was better with the standalone XML. I just wanted to ask if you have tried the new way how the Quarkus distribution of Keycloak is configured via the properties file or CLI options, environmental variables, right? We have a very powerful tool how to configure SPIs.
I'm sorry, I still didn't get all of it. There's a question about have I considered other ways?
Yeah, if you consider the new ways we have in the Quarkus distribution.
Yeah, the ones we're aware of at least are the environment variable mechanisms, which is the mechanism I went over, and then the CLI. My assumption is the same thing but lowercase.
Yeah, so
is there a new way?
You have considered it, yeah? The Quarkus options that we have, the CLI options that we have for configuring SPIs.
Yeah. I mean, I think it's verbose. I'd like the idea of having something that's file based, and if there is a way.
There is a way for file based, of course.
Okay.
Using the Keycloak configuration file.
Okay.
Yeah, so that's I wanted to ask.
Yeah, then I'll update this to include that. I didn't know that.
Okay, thank you.
That's great.
Thanks. I just wanted to add to the previous question. You can run Keycloak config CLI with test containers in your test environment to configure Keycloak for your testing. That's how I do it, and I use basically more or less the same configuration file as I use for the reference environment when I deploy Keycloak for local testing, so you have the same more or less configuration here and there. That works very well. Just an example. But Terraform works the same when you run Terraform from test containers. Right? Okay.
Thanks, everybody.